Hi Coach Ellie and Mr. Miller, this is the tutorial for the tap detection. Let's go. This is the basic code for tap detection. We're going to use the 101 board's onboard IMU to detect a tap and double tap and react accordingly. So first thing we're going to do is include the Curie IMU library right here. And then when we get to void setup, we're going to set the pins 5 and 6 using the pin mode function as outputs. And then we're going to use the Curie IMU dot begin to initialize the IMU. If we don't initialize the onboard IMU, then the Arduino board would never register any of the IMU data. And then we're going to use the Curie IMU dot attach interrupt event callback. So what we're doing here is we're introducing interrupt. So any events that interrupt the loop and tell the 101 board to do something, it'll do that immediately. So what would happen though, the board will jump out of the loop and it will immediately do that function, and then it'll go back to loop. Then we're going to use the Curie IMU set accelerometer range to 3 to increase the accelerometer range to allow detection of stronger taps less than 3 Gs. And then we're going to reduce the threshold to allow detection of weaker taps greater than or equal to 750 milligrams by using the Curie IMU set detection threshold, Curie IMU tap 750. And then we're going to set the time window for the two taps as like a double tap, less than or equal to 250 milliseconds using the Curie IMU set detection duration, Curie IMU double tap. And then we're going to include the Curie IMU interrupts, Curie IMU double tap. And what we're doing here is we're attaching interrupt to the double tap event. So anytime a double tap happens, the 101 board will execute the event callback function. To avoid loop, if nothing's going to happen in the loop because all the actions happen in the callback function. So nothing's going to go on the board. We're going to use static void here, event callback. So if the callback function happens, this is the code that tells us what's going to happen. So if the Curie IMU get interrupt status, Curie IMU double tap. So if it is a double tap happens, and a double tap is detected, and it is on the z-axis negative, so if it's on the bottom of the board, we're going to use the digital write function here to set pin 5 to high and 6 to low. So the RGB LED shall produce a red light. We're going to delay for 500 milliseconds, and we're going to turn it off, setting them both to low. Delay for 250 milliseconds, and then we're going to set pin 5 to high or on again. And then we're going to delay for 500 milliseconds, and then turn both the pins off again and delay for 250. So the RGB LED will flash red twice. Else, we're going to use the else if function here. Else if the Curie IMU tap detected z-axis positive. So if the double tap is on the top of the board, then the green light will go on. So using the digital write function here, we're going to set pin 6 to high and pin 5 to low. So just the green pin will be turned on. We're going to delay for 500 milliseconds. Or turn them off, both of them off using the digital write function, setting them both to low. Delaying for another 250 milliseconds. We're going to turn the pin number 6 back on high, so using the digital write function, and then delaying again for 500 milliseconds, and then using the digital write function again to set them both the pins to low, turning the LED off, and delaying for 250 milliseconds. And that's it. Finally, we're going to use this else function here. So if there's no tap detected, we're just going to set both the pins to low using the digital write function, so the whole LED will be off, no light will be emitted. Here we have the basic board for the tap detection. So here we have the board is connected to the 3.3 volts through this red wire here, and it is grounded by this black wire here from the Arduino board. And then the RGB LED itself is grounded through this black wire here, connecting to the negative column, and then grounded again by this black wire. And then the red pin of the RGB LED goes through this 100 ohm resistor, through this orange wire into pin number 5 on the Arduino board. The green pin for the RGB LED again goes through the 100 ohm resistor, through the green LED into pin number 6 on the Arduino board, and the blue pin goes through another 100 ohm resistor through this blue wire and connects to pin number 9 on the Arduino board. There we go. If we double tap on the bottom, the LED will be a red LED. And if we double tap on the top, it will be green. This is a modified code for the tap detection. So what we're going to do is we're going to use the 101 board's onboard IMU to detect the tap and double tap and react accordingly. And what this means is, depending on if the tap is on the top of the Arduino board or the bottom, the RGB LED will make a different color and the piezo buzzer will sound a different tone. So what we're going to do to begin with, we're going to include the Curie IMU library again and create a constant integer of buzzer pin equals 3, and that's the digital input pin that it is attached to on the Arduino. When we get to void setup, we're going to set, using the pin mode function, we're setting pins 5, 6, and 3 as output. So 5 and 6 are the pins for the RGB LED, and 3 for the piezo buzzer. Then we're going to initialize the IMU again using the Curie IMU begin function here, and using the Curie IMU attachment interrupt, we're including the interrupt function as we did before. We're also again going to increase the accelerometer range to allow detection of stronger taps, and the Curie detection threshold is going to reduce the threshold to allow detection of weaker taps. And then we're going to set a time window for 2 taps and the double tap, so it's less than or equal to 250 milliseconds. And then using the Curie IMU interrupts, we're going to enable the double tap detection. And then again, we're going to start the serial monitor at 9600 BAUD. Again, we have nothing in our void loop because all the action happens in the callback function. Here we are at the static void event callback loop here. So if the Curie IMU gets interrupted because it senses double tap, then depending if it's negative again, we're going to turn again the red LED on, but we're also going to have the piezo buzzer play a tone. Again, delay for 500 milliseconds. It's going to turn off the LED, delay again, turn on the red LED using the digital write function, play the tone, delay for 500 milliseconds, and then turn it all off. Turn the LED off and delay for 200 milliseconds. We're then going to print out on the serial monitor that the red LED was the one that was turned on and the tone equals 262 Hertz. So, and then using the else if function, we're going to determine if the tap was on the negative z-axis, so the bottom of the board. Positive z-axis, the top of the board. Then we're going to have the green LED turn on, and using the digital write function, we're going to set the pin 5 to low, turning it off, the red LED off, and pin 6 to high, turning the green LED on. We're going to play a higher tone this time, using the tone function to 523 Hertz, delaying for 500 milliseconds. We're going to use the digital write function again to turn both the pins off, delaying again for 200 milliseconds. Using the digital write function to set pin 6 to high, turning the green LED on, tone again, delaying for 500 milliseconds, then turning the whole LED off. Again, delaying for the last 200 milliseconds, and then we're going to use serial print ln function to print that the green LED was on and tone equals 523. Else, so if there's no taps, we're going to use the digital write function to set both LEDs pins to low or off, so the RGB LED won't be displaying any light, and no tone will play. There we go. Here's the modified board for the tap detection. So here we have the RGB LED all set up the same way, with the red wire connecting the board to 3.3 volts and the black wire grounding it. We also have a piezo buzzer wired up here, so through the positive side of the piezo buzzer, it's connected through this white wire to pin number 3 on the Arduino board, and it is grounded on its negative side through this gray wire right here to the negative column, which is grounded by this black wire.
there's that.
Here you go.